Hello students, welcome back to chemistry class with Odison Aleko Adiola. And in today's class, we are going to be looking at preparation of solution, specifically how to prepare standard solution. This video is brought to you by Agotha Virtual Learning. Our major objective today is to prepare solutions of various concentration. Now let's look at some of the definition of terms. Number one is a standard solution. A standard solution is a solution with a known concentration of a substance or element. A standard solution is a solution with a known concentration of a substance or element. What do we mean by concentration? Concentration is the known and accurate amount of a substance or element in a solution. Concentration is the known and accurate amount of a substance or element in a solution. For instance, when you have a particular acid, let's say you have an acid solution, for instance, when they say the acid is concentrated, that means the level of the amount of acid in that solution is high. That's what we say it has high concentration. The amount of a particular substance in a solution, that's the concentration. Now, when we say molarity is the amount of moles of a substance in 1 liter solution. In a 1 liter solution is the amount of substance in a 1 liter solution. Sometimes you can also say that is the number of moles of a particular substance per unit volume in a solution. The number of moles of a particular substance per unit volume in a solution. Another one we need to know is the formula mass. The formula mass is the total mass of a compound calculated by adding the atomic mass of each atom in the compound. The total mass of a compound, which is calculated by adding atomic mass of each atom in a compound. It is also called the relative molecular mass, which is the sum of all the atomic masses of elements in a particular compound. Let's say you have sodium thiazocarbonate 4, for instance. The formula mass will now be the sum of atoms of sodium inside that compound, which is 2 Na, plus the sum plus carbon, which is 1, plus oxygen, which is 3. So the formula mass is total mass of a compound calculated by adding the sum of the relative atomic mass of each atom in the compound. Another one is to look at primary standard. A primary standard is a reagent with specific characteristics that can be used to accurately assess the unknown concentration of a compound, of a substance rather. Now let's look at typically a primary standard. Very important. A primary standard is a reagent used in analytical chemistry or generally in experiments, and of course it has the following substance. Number one, high degree of purity. The primary standard that you want to use must be pure. A primary standard is usually pure, and then its weight represent the number of moles of the substance it contains. The weight of a primary standard is equivalent to the number of moles of the substance it contains. Number two is that a primary standard is stable. That means both in its pure form and in solution, the standard is the same and stable. Number three, low hygroscopy. A primary standard doesn't absorb water or other substances from the air and will change its weight and purity. Hygroscopic substances are substances that absorb moisture from the atmosphere and of course do not dissolve it in it. So it will, even if it absorbs water moisture from the atmosphere, it doesn't dissolve in it. And of course, that one will not affect its weight and its purity. Another one is high equivalent weight. A permanent standard have high equivalent weight that minimizes weighing error. It remains unchanged for a long time. It remains unchanged for a long time so that it can be used over time. Then it is non-toxic. It is readily available. It is soluble in the same solvent as the compound being tested because it is a standard. A permanent standard is usually a reference point in a particular experiment or in a particular analysis, and of course, it must be soluble in the solvent of the compound we are trying to test. If you have a permanent standard A, and then we are trying to analyze compound B, if compound B dissolve in water, the primary standard must also be able to be dissolved in water. It must be soluble in the compound being tested. It must be soluble as the same in the same solvent as the compound being tested. It must react reliably. It must react reliably. Okay, so another one that we look at is a stock solution. Under stock, when we are studying standard solutions, we will also look at stock solution. A stock solution is a concentrated solution of a chemical substance that is used to make more dilute solution. Is a concentrated solution of a chemical substance that is used to make more dilute solution. They are usually used in the laboratory and can be used on their own or part of a complex solution. Now, for instance, in the laboratory, you will see that they usually place some substances on the shelf. For instance, we can place concentrated H2SO4, concentrated H3PO4, HCl, HNO3, etc. And of course, sodium hydroxide pellet or potassium hydroxide pellet directly from the company. They are in their concentrated form. However, if we need to dilute it and use them for other laboratory works, we can decide to dilute and then use them as well. So the way they come directly from the company, they are known as a concentrated or a stock solution as at that time. So for a stock solution, we use them to make dilute solution, or in fact we can also use them to make on their own. They can be used on their own for some laboratory practices or activities, or they can be made to mix with other solutions for other purposes. So some of the characteristics of stock solution are: number one, accuracy. They help us to reduce errors because it's easier to be accurate when measuring larger volumes. They are usually accurate. Of course, their measurements usually come with on the pamphlet or with the label that it comes with. They usually put their measurements there, and of course, it's usually accurate. Number two is that some of the advantage they also have is that the convenience. They can be made in advance and used multiple times. And then concentration. High concentration of substances in stock solution can prevent the growth of bacteria, fungi, and mold. Another one we look at is normality and molarity. And when we are looking at standard solutions, these terms are very important. Normality is the number of equivalent of a solute divided by the volume of the solution in liter. It is the number of equivalent solute divided by the volume of solution in liter. It's also known as equivalent concentration. An equivalent is how much the solute will react with a set of another reactant. So normality is also known as equivalent concentration. Usually we can say mathematically that it is the number of equivalents of a solute divided by volume of solution in water. Then molarity is the number of moles of solute dissolved in 1 liter of solution. Number of solute dissolved in 1 liter of solution. To calculate it mathematically, you can say molarity is number of moles or amount of substance in mole over volume in dm cube. We can relate them mathematically like that. Now let's focus on first how to calculate molarity. To be able to calculate the molarity of a particular substance, we can use this example. Please note, before we go into this example, we can have mass concentration or molarity in terms of gram per dm cube, and then of course in terms of mole per dm cube. But here our focus is usually on mole per dm cube or molar. But wherever you see molar, is the same thing as moles per dm cube. That means that the amount of substance in mole over volume in dm cube, that's mole per dm cube, or you see it written as molar. Now let's take this example. The question says a solution is prepared by bubbling 1.56 gram of hydrochloric acid in water. Here the volume of the solution is 26.8 ml, that's milliliter. Calculate the molarity of the solution. Let me repeat again. In doing the calculation, don't be confused. The question a particular student will ask is, what about the ones that usually give in mass over volume? That's gram per dm cube. Yes, that's mass concentration. Please take note. And of course, we have molar concentration, which is number of moles over volume. But when we talk about molarity, it's focusing on the number of moles or amount of substance over volume, which is mole per dm cube or molar. Please take note. So here we are dealing with the molarity, and to make it easy for you, the first thing to do is to convert that mass to mole. And if you see questions like this, you convert the mass to mole, and that is number of moles is equal to mass over molar mass. Then you look for the molar mass of hydrochloric acid. H is 1, Cl is 35.5. So the molar mass is equal to 1 plus 35.5. That's 36.5. And the mass given there is 1.56, and that's 1.56 over 36.5. It will give you 0.0427 moles. That's the first. The next thing is now to convert it to molar concentration, or find the molarity. To find the molarity, we have said molarity is equal to the number of moles or amount of substance in moles over volume in dm cube. That means we need to convert that ml to liter. 1 liter is equivalent to 1 dm cube. 1 liter is equivalent to 1 dm cube, and then 1 dm cube is equivalent to 1000 ml. 1 dm cube is equivalent to 1000 ml. That means 1000 ml, or 1 liter rather, is equivalent to 1000 ml. So to be able to convert that ml to liter, you are going to do 26.8 divided by 1000. 26.8 divided by 1000, and that will be 0.0268 liter. 0.0268 liter. that if you have divided by 1000, then you now find the molarity. That's the n now, amount of substance 0.0427 over 0.0268. It will give us 1.59 molar. 1.59 molar. That's how to find the molarity. Now let's also look at how to calculate for normality. How to calculate for normality. The question says to find the normality of a 15% HNO3, that's nitric acid solution. We can use the following steps. We want to find the normality of 15% HNO3. The first thing to do here is to calculate the mass of HNO3 in 1 liter of solution. We have to calculate the mass of HNO3 in 1 liter of solution. If we say you have a 15% weight per volume solution, it means that we have a 15% HNO3. What we are saying is that we have 15 grams of HNO3 in 100 ml of solution. So whenever you see 15% HNO3 solution, what it means that we have 15 gram in 100 ml of solution. Hence, in 1 liter, therefore that is 1000 ml. We are going to have the mass of HNO3 to be equal to 15 over 100 times 1000. What do we mean by that? Don't forget that we want to be able to calculate very well. Our volume must be in terms of 1000 ml or 1 dm cube. The volume must be in a standard form, which is 1 dm. Our 1 dm cube is the reference point here. So if 15 gram is equivalent to 100 ml, then S gram will be equal to 1000 ml. If you cross multiply, you are going to have 15 gram over 100 times 1000, which is equivalent to 150 gram. So you are going to have the mass of HNO3 will be 150 gram in 1000 ml of solution. So we have been able to standardize that one. The next thing we are now going to look at is to convert that mass to mole. And that is 150 divided by 63.01, because the molar mass of HNO3 is 63.01 gram per mole. That's hydrogen 1 plus 14 plus 16 times 3. That's 1 plus 14 plus 48. That is 63. That is the molar mass of HNO3. And then you are going to have it as 150 over 63.01. That's 2.38 moles. 2.38 moles. 2.38 moles. So to determine the normality now, we can say for HNO3, it's a strong acid. So if it dissociates, you are going to have H plus NO3 minus. So it will dissociate completely to give 1 proton. That's 1 plus those. So 1 H plus. The basicity of the acid is 1. Therefore, the volume of the solution is 1 liter. So the molarity and normality is equal to, normality now is equal to the number of moles of HNO3 all over the volume of solution in liter. That's 2.38 over 1 liter, and that will give us 2.38 normal. That's N. So the normality of a 15% HNO3 solution is 2.38 N. 2.38 N. So normality therefore can be now be said that, and we can say our normality is equal to molarity times basicity of the acid. in the same way we look for molarity. Molarity is number of moles, or amount of substance in mole over volume in dm cube or in liter. So if you have done that, that means you would have gotten 2.38. Then multiply by the basicity of the acid, and the basicity of the acid. So you can find the molarity of that particular substance and multiply it by basicity. Basicity of HNO3 is 1. So you still get the same answer. Now, to find the molarity of the solution, we can consider, if you want to use this method, for instance, we can use this method to also solve for that particular question. We are using another method now. To find the molarity of the solution, we can consider the following information. We want to use another method. You have 15% HNO3, and then you know that the density of the solution is 1.12 gram per mole. Usually, if each of the acid, especially the strong acid, usually have specific gravity or density, and the specific gravity of HNO3 is 1.12. So that means that we have 1.12 gram per 1 mil. That is the interpretation of this density. Now you have 1.12 gram per 1 mil. And that means if you put it, if you multiply it by 1,000 to put it in a standard form, a standard format, that means you are going to have 1,120 gram per 1,000 mil. Don't forget, we are usually raising it to 1,000 mil because 1,000 mil is equivalent to 1 dm cube, which is the standard volume we are using. So 1,120 gram, we have 1,120 gram per 1,000 mil. That is the implication. So in every 1 liter of the acid, there are 1,120 gram of HNO3. So to calculate further, now we have interpreted that the next step is that they said the solution is 15% of HNO3, which means that 15% of the total mass of a given volume of the solution is the HNO3. Now what it means is that for the 15%, that's 15 over 100 times 1,120. Let's go back so you can understand. We want to use another method to solve for normality. And we have said that normality is equal to molarity times basicity of the acid. Now we now said the basicity of the acid is 1 because it is equal to give H plus NO3 minus. We've known basicity. Now we want to look at the molarity of the solution. We now said to find the molarity, we want to use, because we are not given any other information apart from 15% HNO3. We now say that, but HNO3 has density. It has a specific gravity, which is 1.12. Now, to interpret 1.12 gram per mil, that means that for every 1 mil, you have 1.12 gram. To take it to standard form, which is 1,000 mil, that means you multiply by 1,000. That's 1.12 over 1 times 1,000. You have 1,120 gram per 1,000 mil, or per 1 dm cube, or per 1 liter. So for every 1 liter, we have 1,120 grams. Now, to also do not find the 50%, because it said 15%, that means you have 15%. The HNO3 there is the 15%, of the total mass of the HNO3. So to find 15%, now we just say 15 over 100 multiplied by 1,120. That is 168 gram. 168 gram. So to now find the number of moles, now we are going to find the molarity. Since we now know the mass of HNO3, now we now see the number of moles therefore is equal to mass over molar mass, which is 168 over 63, and that's 2.7 mole. 2.7 mole. Now since we are using 1 liter, so number of moles over volume. To find the molarity, the molarity now be equal to number of moles over volume, which is 2.7 over 1, because we are using 1 liter, and that's 2.7 molar. So the molarity of that solution is 2.7 molar. Now we now go back to the initial formula. Normality is equal to molarity times basicity, and the molarity here is 2.7. The basicity of the acid is 1. That's 2.7 over times 1, and that is 2.7 normal. So the normality is 2.7. Now if you go back to this, the first one was 2.38. This as a result of approximations and the like, but they are still within the range. So whether you use the first formula or the second formula, you are going to get the normality. So you must know that to avoid possible error in the interpretation of data, one needs to be sure which of the percentage concentration is given the problem. You have to be sure. Are you giving weight per weight, weight per volume, or volume per volume? You must be very sure of the percentage concentration, so you know which one to use. It is very important. So we have looked at how to calculate molarity and normality, and how normality is related to molarity. Now let's go to the calculating the standard solution. We have said standard solution is a solution of known concentration. We have said standard solution is solution of known concentration. Usually the materials you are going to need when you are preparing a standard solution, whether we are preparing a standard solution of acid or base, ensure you have your funnel, either your funnel or aspirator. Make sure you have your funnel. Make sure you have your measuring cylinder or graduated cylinder, depending on the size of what you want to put. For instance, you may want to weigh, if it's a liquid, for instance, you may want to weigh or measure 100 ml, 200 ml. So depending on whatever volume you want to measure, make sure you have the graduated cylinder or measuring cylinder that is equivalent to it. Then again, you must have standard flask or volumetry flask. They are of different range. You have the 100 ml, 500 ml, 1000 ml, etc. 1000 ml is equivalent to 1000 centimeter cube or 1 dm cube. So you must have the cylinder, you must have your beaker, you must have your stirrer or stirring rod or glass rod. You must have your wash glass. Usually for the base, they usually come in solid form. So we usually put them with the base in the wash glass. So it is very important. You have your spatula, because if you are measuring base, for instance, you have to use your spatula to put it inside the wash glass before you move it to the beaker. You must have your empty reagent bottle. Because you may need them. You will need them to, after preparing the solutions, you can transfer them into the reagent bottle. You will need your pipette. Most of the time, you usually use to measure water, the exact number of amount of water that you need, and then sometimes you may even need to have a dropper if you need to add 1 or 2 drops to it. So these are materials you need in preparing a standard solution. These are the materials you need in preparing a standard solution.